in the solution to
Yeah,
the
yeah, might.
homogeneous part.
Which, just a second. Yeah, yeah. Now,
Yeah, sure.
let me just repeat it in a bit. So we considered this Langevin equation. Now, not Langevin. We considered this question 5 of your. This was our SDE, okay, and then we considered A1, A2, B1, B2, okay. Then we calculate this phi of T naught to T. So you are asking some question. Now you ask.
So in the first equation that we tried to solve, we got as a solution to the homogeneous part.
Yeah, which was this one.
We got that the phi was equal to x naught exponential.
Yeah, so that was you can now ignore that even because
So we don't need to worry about that.
that part is contained in it. Even you can recover that part from here.
Okay, okay.
It's just you. What was that? dxt was equal to a1x plus a2 times dt plus your b2 dwt. So your b1 is going to be 0, right? So you just set b1 to 0 and your most general you will get this and your phi will be accordingly settled.
Fine.
Okay. So now you calculate as this phi of t naught to t, which is this. Okay. And then finally you insert these values here. So you get x of t to be equal to e to the a times t minus t naught x naught plus this is going to be b times t minus t naught plus this is going to be t naught to t. This is going to be e to the minus a s minus t naught. You will later on figure it out how it is coming. So you can just, if x naught is 0 for the moment, let's say, or if x naught is x, in our case it was x naught equal to what? Just let me show you what was x naught equal to in our case. So in our case, where is it? So yeah, so this was question 5 and our x naught was equal to this x. We will use this x naught as x, okay? So x naught is basically x, so you can write in place of this x. So x of t is equal to e to the a t minus t naught times x plus b times t minus t naught plus t naught to t e to the minus a s minus t naught dws. This is going to be the solution. Now you can even multiply this, okay, like a into t minus t naught times x plus b into t minus t naught plus e to the a into t minus t naught to t e to the minus 8 s minus t naught and dws. Okay, now let's see what is the solution of that time when we were solving it. So okay, so here it is. Okay, let me show you what was the solution and we will compare it over here. Yeah, yeah, so that's it. Yeah, so let's go to this. Now let's come to this question 5. Yeah, okay. So that was question 5. So you can see this question 5. The solution was this over here. This was here, the solution. Is it same as the one we have? Like, no. Sorry. This is the solution. Yeah, this is the solution. This one. I'll compare it with the one we have got right now. In a while. Okay. Okay, so now you can compare these. Okay, by the way, why have we missed this A? Where have we made this mistake? What is A2? Hello?
So
Your
A2 is B, right?
Yeah, A2 is B. What was A1? It was A. So A2 was A. Oh, so this A2 was A, and I have kept this as B. Oh no. So I made a little mistake. Will you repeat the process by yourself?
But A2 is B, right?
Should we redo? Should we do it again to get the same answer?
Yeah, we can do it again. We can do it
Yeah,
again, yeah.
yeah. So what was the equation? Let me write down the equation properly at first. So the equation was dxt to be equal to, yeah, it was dxt to be equal to ax plus b dt. Yeah, right. Oh yeah, sorry. Dxt was equal to ax plus b dt plus dbt, let's say. So our a1 is a, a2 is b, b1 is 0, and b2 is 1. Now we calculate phi. This is my phi. Okay, so what is going to be our phi? Phi is going to be equal to exponential of, okay, let's take this limit from 0 to t, because it's just a convention. Sometimes you take 0 to t, sometimes you take t naught to t. So because in question 5 it is 0 to t, you can see there. So you will just take this t naught, in place of t naught you will take this 0 to t. Even in your course you can always take this 0 to t, no issue at all. So what is a1? This is a minus 1 over 2 b1 square. So b1 is 0, and ds, because this b1 is 0, so this is 0, which is
If B
exponential
was
of a
if B was
times.
5, if B1 was 5, for example,
Oh yeah,
then this half B squared S, what would that be?
yeah. Then you should have written here b1 value, and then this guy would have come. Like for example, if b1 was equal to 5, then our 5 would have been exponential of 0 to t a times. Okay, so here also 5 is square, 25 over 2, then ds plus 0 to t. You also write 5 here, 5 times dw. Okay, so then 5 would
Wait,
be,
wait, wait, wait.
yeah.
Wait, this I'm confused about the beta, the B1, the B1 squared.
So you are taking v1 to be 5.
Yeah, what would the half B1 squared term be?
Yeah, it's going to be 25 over 2.
Just 25. Okay, fine.
You are getting?
Yeah, fine.
So let's go back to this. So this phi in our case is going to be exponential of at. Okay, or you can maybe write e to the at. Okay,
Mm-hmm.
now you got phi for our this.
Is it, wait, is it, wait, hold on. Is it 80 minus 1?
I'm going to wait. Just a second. I'll answer your every question. Yeah, that's right. Just still here.
Is it 80 minus
Yeah,
1?
yeah, yeah. You can now answer it. Yeah, you can ask any question now. So
Is it
our
80 minus 1?
where?
Um,
No, why minus one?
sorry?
Yeah, ask me question. Yeah, you can ask me question.
It should either be exponential of 80 minus 1.
Exponential of 80 y minus 1, by the way.
or minus hold on. What?
A
T
minus
0
0.
exponent
So A is coming here. So just integrating. Should I redo? Should
minus.
I re? If you ask, I can do it again.
Wait, hold on.
Just a second.
So when
Like see this. Now let's not be hurry. So phi t is exponential of 0 to t. And then my a1. What was a1? A1 was equal to. So you can just
okay.
a1 is a. Okay. Minus b1 is 0.
Mm-hmm.
ds plus 0 to t. It is again this b1 is 0.
So you get x, which is equal to exponential of t of a t to t0, which is equal to exponential of a t. The e to the 0 is just 1. So exponential.
I've just simplified this guy. It is coming here, and then just simplify this. It is coming here.
No, so
Yeah. Ask me.
you know when you integrate exponential of t to 0, exponential of a between t and 0 ds, right?
Mm.
When you evaluate the integral of a with the limits of t and 0, you get at minus 0, right?
I think it's fine now because a is a constant, so I can select
Yeah,
it out.
sure. Yeah. Sorry, actually, I made a mistake. Yeah.
Fine now.
Yeah, fine.
So our phi is going to be this. So first step is always to calculate phi. We have got this phi.
Mm-hmm.
Now we use this finally. This x of t equal to this phi of t to t naught, which is this e to the at. Okay. This x
Mm-hmm.
of t naught is x. You can check this from our question. 0 to t. What is our a2 now? A2 is b.
It will
A2
be.
is b. So I'll write this b minus a1 or b1 and b2. B1 and b2 because b1 is 0, so their product is 0. What is going to be phi of this guy? Phi of S inverse. So you just take the inverse of this. So this is going to be e to the minus as. You need this now. What is this?
It is minus.
What is our phi s? It is going to be e to the as. Like if it
Yeah.
is phi of t, then so you just take its inverse. So it's e to the minus as.
Yep.
So you just substitute this e to the minus as ds plus 0 to t. What is our b2? B2 is 1. You can see this is b2. It is 1. So you just substitute b2 as 1. And what is this? This is same, this guy, e to the minus as dws. You are getting me? So your x of
Yeah.
t is
Yeah.
going to be e to the at times x plus 0 to t b e to the minus as ds plus, if you remember, we are where we needed to be, right? So you just integrate this. X of t is going to be e to the at x plus, this is going to be b e to the minus as ds plus 0 to t e to the minus es dws. So x of t is going to be e to the at times x plus b times this integral will be minus as over minus a 0 to t. So you just take these limits and you will get x and minus, and this is just going to be b over a, and e to the minus at, and then you substitute 0, so this is 1 plus 0 to t e to the minus as dws. Or maybe you can write x of t to be equal to e to the at x plus, you can multiply this and you get b over a 1 minus e to the minus as plus 0 to t e to the minus as dws. Okay, and last time when we solved it, so our solution was this. So you just compare this. Just compare this. Okay, just compare these both. Is it exactly the same?
Yeah. Yeah.
What this is dbs, like it doesn't matter. Dbs is same as dws, like, okay. So what does this mean? So what is the conclusion of this? So if you are given with SDE, I'll say in particular linear SDE, and hopefully you will always be having linear. You will not go into non-linear because that's a very kind of hard area. Um, Majority of the people don't touch that area. So if you are given with any linear stochastic differential equation, then either you will get hint from your professor, you will get hint from your professor to solve. Okay, if you don't get hint, then follow the procedure that we have had. Follow the above procedure. Sometimes you get hints, like the last time when we were doing this question. So he has given us a hint, and the hint is this: apply integration by parts, which we did last time. I mean, we considered yt to be x t e to the minus at, and then we took this dyt dx, then e to the minus at same, and then minus a e to the minus at dxt, and then we had solved last time this one. Again integrating. But if your professor is not giving you the hint, then you just go and remember the procedure that we have done today for this linear equations. You can solve now any linear SDE by following the above procedure. Yeah.
Good.
Yeah. So now let's move to the question number. Let me tell you this question number. Just a second. Question number. Just a second. So you can see this. Question number 6 we were discussing, right?
Yeah, number 6. Yeah.
So we will do this now. Okay. So let's take this to our Word file. Okay. So we are here. Control V. So here it is Feynman Kac representation result. So we will use that. So let me go into your note, your professor's notes, and then so that, yeah, here, just come here. This is yeah. You see that? So there isn't this x actually. This is mistake here. Okay, so I'm kind of explaining to you how this Feynman Kac has the representation.
Mm-hmm.
So the way I have like kind of understood after before a few hours, when I was just preparing something for you, then I saw that if you are giving with this as dxt equal to like mu dt plus sigma dwt, yeah, dbt with some initial okay, so let me bring that also, the result that I have in my head. Let me bring it over here. Huh?
Mm-hmm.
So if our SDE has that particular form, like this form, and we want to solve this this PDE, this kind of PDE, then its solution is given by just this. Okay, so I'm explaining you this like in my own words. Okay, so consider now we have an SDE of this form dxt to be equal to a of t dt plus b d v of t dwt. Then the process, suppose this x of t is satisfying this differential SDE, and we are interested in solving this partial f by partial t plus a of t partial f by partial x plus 1 over 2 b square partial f by partial xx equal to maybe some constant, or sometimes maybe it's 0, and subject to some initial data, and the initial data is going to be some, let's say for our case it was f of t comma x equal to e to the x. Okay, so we want to solve this, like we want to solve this this PD with the help of this SD. So this PD is called Fokker-Planck PD. We want to solve this PD, but we will use the help of this SD. And when we do this, all of this is called your Feynman Kac formula. So Feynman Kac says that if you want to solve this SD, this PD, you take the solution of this SD and calculate the expectation of uh, this is sometimes phi of x. So you calculate the expectation of phi of x of t given ft. You got that. So we will just calculate this, and this, whatever this is, will be the solution to this. So we just need to
Mm-hmm.
calculate this thing. Okay.
Yeah.
So in other words, in our case, f of t comma x is basically e to the x of t.
How did we get?
Huh?
How did we
Yeah,
get the e to the x?
just from initial data. Oh, sorry, boundary data. This,
Oh,
this,
right,
this,
right. Human.
this one.
Yeah.
So this is our f of t comma. Maybe you can write it phi of t e to the x of t. So this is my phi. What I need to calculate is I need to calculate expectation of e to the x of t given ft. Right? I need this. If I calculate this, whatever this is going to be the solution of my PDE, this PDE. That is what I needed to
Mm-hmm.
do. So we are all we have to do is just to calculate this guy. So let's work with it. Let's see how can we calculate that. Okay. So okay.